Good afternoon, teachers and friends. I'm Ali Atika. Today, I'll be presenting to you my research and architecture for my Nature and Systems project, Crytosperma mercusi inspired. This will be the contents for today. An overview of the Crytosperma mercusi plant. It is a leaf that lives in wetland in humid habitats formed in clusters. Other features include its sharp arrowed ends and its distinctive split end. One of the first few key features that intrigued me about the plant was how it grows into different angles, some of which can be extremely straight with two or one point facing down or simply flat with 3 points facing down, as you can tell from my visual over here. This orientation of different angles provides different points of efficiently channeling the water of the leaf. Let me further explain on my genius, which is the water drainage system in the Crytosperma mercusi. What you see here is the concave convex abaxis mechanism. For example, if a water droplet were to flow from the highest to the lowest point, it has a certain channeling of how it will flow off the surface. This feature helps in reducing capillary resistance and increases gravitational pull on the water droplet. This would be my site where there is a continuous water system, which is the fountain. This is crucial in showing my genius of water drainage. When I first thought of my idea, I wanted to arrange the lifts that will further enhance this water drainage system into an architecture. However, I needed to find ways to ensure this pavilion has less obstruction and focus more on the stability of the pavilion. I then designed something similar where there is a proper channel for the water to flow off the pavilion. With this design, I learned more about how to make the water flow a more interesting experience, which is the clicking sounds coming from the water flowing down. From my previous idea, I developed sub ideas which will lead to my main idea. Firstly, I mimic the concave convex mechanism for the leaf structure, which will make the and use metal to make the structure. This is to amplify the sound and reduce friction for the water flow. For its mechanical support, cantilevered beams will frame these leaf structures together, creating a floating effect to the pavilion, which is something I wanted to show. For stacking, this is important in ensuring that there is a direction for the water to flow. Finally, I gathered my ideas into a design which the water drainage in the site becomes an enjoyable experience for the humans. The continuous water will come from the fountain found in the middle of the hole from my plan. For my 3D models, students and teachers can walk on the bridge hearing the vibrations and clicking sounds of the water draining off the roof and avoid getting wet from the fountain water. Not only that, my architecture provides benches. From this walkthrough video, you get to have the experience of being on the bridge. There are railings provided for safety measures as well. Moving on from my final model, I mimic my architecture to learn more on how my pavilion will work.